Welcome back. Semester 2, we are going to talk primarily about trigonometry. And before we jump into trigonometry in chapter 4, we need to review special right triangles. There are two special types of special right triangles, our 45-45 90-degree triangle and the 30-60 90-degree triangle. Okay, a 45-45 90-degree triangle is a right triangle, okay, which means I have one right angle, in which the other two angles are both 45 degrees. Since these two angles are congruent to each other, this is going to represent an isosceles triangle in which two of the three sides are congruent to each other. The ratio of sides for a 45-45 90-degree triangle is 1:1 to radical 2. What that means is that my two congruent sides could be any number, but they always have to be the same since the sides are congruent, and the hypotenuse, or the longest side, will always be that number times the square root of 2. A 30-60 90-degree triangle is also a right triangle. It has one 90-degree angle. Okay, the side opposite that, the hypotenuse, is going to be twice the length of the shorter side. Okay, and the longer leg is going to be radical 3 times the length of the shorter leg. Now, in a 30-60 90-degree triangle, we have one right angle. This is the largest angle, so it will always be across from the longest side that we call the hypotenuse. Our two acute angles are the 30-degree angle and the 60-degree angle. The 30-degree angle is the smaller of the two angles, so the side opposite that we call the shorter leg. That's always going to be x. Okay, 60 degrees is longer, so the side across from 60 degrees is our longer leg, and our long leg is equal to radical 3 times the short leg. The ratio of sides of a 30-60 90-degree triangle is 1 to radical 3 to 2. We are going to use this information to find the missing sides of special triangles without using a calculator. Okay, in problem number 1, we have a 45-45 90-degree triangle. Okay, so what I know is that my two shorter legs are congruent to each other, and the ratio of the sides is x to x to x radical 2. Now, what I know is that x is equal to 9. So if the top side is 9, the side to the right must also be 9. Now, the hypotenuse is x radical 2, so the hypotenuse would be 9 radical 2, since we know the value of x is equal to 9. Now, let's look at problem number 3, as 3 is also a 45-45 90-degree triangles. Now, I know the ratio of sides is x to x 2, the hypotenuse is x radical 2. Now, in order to find the missing side lengths, I need to find x. Now, what I know is that x radical 2 is equal to the length of 14. And I'm going to use this equation to solve for x. I'm going to divide both sides by radical 2. So I see that x is equal to 14 divided by radical 2. We cannot have a radical or a square root in the denominator, so I'm going to multiply the numerator and the denominator by radical 2. This is called rationalizing the denominator. So 14 times radical 2 is 14 radical 2. Square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2, so my denominator is 2. Finally, I can divide 14 by 2, which is 7. So x is equal to 7 radical 2. So I know that this length is 7 radical 2. And the left side is also 7 radical 2. Okay. I would like for you to pause the video, try problem number 4. When you're done, hit play, and I will go through problem number 4 with you. Okay, problem number 4 is a 45-45 90-degree triangle. Okay, my ratio of sides, starting with the two congruent sides, is x and the hypotenuse is x radical 2. Now, I know that x radical 2 is equal to 9. So I'm going to set those two expressions equal to each other, and I'm going to solve the equation for x. I'm going to divide both sides by radical 2. I see that x is equal to 9 divided by radical 2. I cannot leave a radical in the denominator, so I'm going to rationalize. I'm going to multiply the numerator and the denominator by radical 2. And we multiply fractions straight across. 9 times radical 2 is 9 radical 2. Radical 2 times radical 2 is radical 4. Square root of 4 is 2. We typically do not write decimals with the radical, so I would keep this as 9 radical 2 divided by 2, as I cannot simplify 9 over 2. So the length of each of my two sides is 9 radical 2 divided by 2. This is my exact answer, and we're going to be keeping exact answers pretty often in second semester. Okay, that takes care of the 45, 45, 90 degree triangles. Next we have 30, 60, 90 degree triangles. Okay, in a 30, 60, 90 degree triangle, we have a shorter leg, a longer leg, and the hypotenuse. The shorter leg is x. The longer leg is the leg across from 60 degrees, which is x radical 3. And the hypotenuse is twice the length of the short leg. The hypotenuse is the longest side, that is 2x. So we need to find the length of the two missing sides. Now, I know the longer leg is 21, so I'm going to take x radical 3 and set this equal to 21, and I'm going to solve this equation for x. I'm going to divide both sides by radical 3. So x is equal to 21 divided by radical 3. Again, I have to rationalize the denominator. So I'm going to multiply the numerator and the denominator by radical 3 and multiply straight across. 21 times radical 3 is 21 radical 3. I just smush those together. Radical 3 times radical 3 is 3. Square root of 3 times the square root of 3 is 9. Square root of 9. Square root of 9 is 3. Again, I can take 21 and divide it by 3. That's 7. So x is equal to 7 radical 3. So what I know, x, or my shorter leg, is 7 root 3. Now, to find the hypotenuse, I take 2 times x. So if I take 2 times 7 radical 3, this is equal to 14 radical 3. I multiply the 2 and the 7, and I keep what's in the radical alone. Okay, problem number 5. Okay, 30, 60, 90 degree triangle. The shortest leg is across from 30 degrees. This is x. The longer leg is across from 60 degrees. This is x radical 3. The hypotenuse is across from the 90 degree angle. This is 2x. I need to find the shorter leg and the hypotenuse. Okay, I know the longer leg is 10, so I'm going to take x radical 3 and set this equal to 10. To solve for x, I divide both sides by the square root of 3. So x is equal to 10 divided by radical 3. And I cannot keep a radical in my denominator, so I'm going to multiply the numerator and the denominator by radical 3. Multiply straight across. 10 times radical 3 is 10 radical 3. Radical 3 times radical 3 is 3. I cannot divide 10 by 3. So this is the exact answer that represents x, which is the shorter leg. Okay, so the shorter leg is 10 radical 3 divided by 3. Now the hypotenuse is 2 times the shorter leg. So I'm going to take 2 times 10 radical 3 divided by 3. Now 2 as a fraction is 2 over 1. and we multiply fractions straight across. So 2 times 10 radical 3 is 20 radical 3. And in my denominator, 1 times 3 is 3. Again, I cannot divide 20 by 3. Okay, so I keep my hypotenuse as 20 radical 3 divided by 3. Do not write it as a decimal. Keep it as a fraction. Okay, I would like for you to try number 6. So pause the video. Once you attempt number 6, hit play, and I'll walk through number 6. Number 6 is also a 30, 60, 90 degree triangle. Okay, the side opposite 30 degrees is the shorter leg, that's x. The side opposite 60 degrees is the longer leg, that's x radical 3. Okay, the longest side is the hypotenuse, that is 2x. Okay, I know the hypotenuse, so I know that 2x is equal to 20. If I divide both sides by 2, x is equal to 10. So I know that the shorter leg is 10. And if I plug in x for the longer leg is 10 radical 3.